Hello everyone, how has your day been going? Today I want to explain the equations of motion to you. So before I start teaching the three equations of motion, I assume actually that we all know S is equal to distance by time. S is speed here, but later on you'll see that we'll use S here as distance. So this is not same as this S here. Next, I also assume that we know acceleration is final position of the body minus initial by the time. Now that we know these two formulas here, I'm assuming that we know. If we don't, please leave a comment in the comment section and I will personally explain it to you if I'm free that time. But I will definitely get back to you. So I'm assuming we all know this. Now let's go on with this. The first equation is v is equal to u plus at. Now how to derive this? Now what's the point of deriving all this is that it will not only bring in the interest, but also that it'll be easier to solve numericals. That way you will be able to understand and you won't actually be mugging up all these concepts. So let's go ahead. Now we know that a is equal to, now we also know that a is equal to v minus u by t. Okay, now if we rearrange this t, we bring at, this t comes here. We all know how to cross multiply and transpose, and we bring u also here. So v minus u, this is at is equal to v minus u. We got that. Now we can bring at plus u, because it was minus here, and we can do is equal to v. So we got the first equation of motion right. Now second equation of motion, what's important is doing this in order, because we'll be using the first and second to derive the third one, and the first one to derive the second one. So let's go ahead and do that. I hope you all also know that these are the terms which we're going to be using today. V is the final position of the body, U is the initial position of the body, S is distance, A is acceleration, and T is time. So if we take that, AT, which is acceleration into time plus initial position of the body where it started from, is equal to the final position of the body. So with that we can find the final position of the body. Now let's go for the second one. Let's go ahead. So the second one is S, which is distance here. I talked about it at the starting. S is distance here, is equal to u into t, which is initial position into time, plus half a, that's acceleration, into time square. Now we need to find this, how we derive this. It's actually very easy to do this, but to derive it, people find it a bit hard, because deriving is actually pretty hard. So how exactly do you derive this? We know that speed is equal to distance by time, and we know that we know this formula. So if we fill in the values, we will be able to find this, and I will show you how to do it in just a minute. So we'll have to rearrange this again in that way. Excuse me. We'll have to rearrange it in that way so that we are able to find it. So let's go ahead and do it. Alright, we're back now to derive this equation. So let's go ahead with deriving this. So we know that average velocity is average. I'll write this as AVG because I'm not trying to waste time here. V plus U by 2, because final plus initial by 2, that's average. You can do that like that way also. We can do that's what we do, because if you want to take out average of one thing, two things, suppose it's 2 plus 10. Now these are the two people in one class, and we want to find the average marks they got, and this is their marks. So 2 plus 10 by 2, which will be let's just say 6. It's 6. 12 by 2. I was about to do that, brother. Go ahead and do this right now. Now we know this, so and we can write distance, which is S, is equal to average into time, average velocity into time. we need to know this. Distance is equal to average velocity into time. Now if we take that, we do S is equal to u or v plus u, it doesn't really matter that much, by 2 into t, which is t here. Now if we fill in the value, we know the value of let's say v, we know the value of v from here. V is equal to u plus at. So if we do this here right now, S, which implies S is equal to u plus at by 2 into t. Now moving on here, let's just do this here, and if we solve this equation, you will get u plus u is 2u plus 2u plus at by 2, don't forget the brackets, into t. Now if we look at this properly, it's S is equal to ut square, because if we solve this, ut square at square plus, this is u, do not confuse this for a, ut plus half at square. I was trying to put this at square first, but it's actually not. Keep in mind that only t is squared, not anything else, not a, not half. So if you square all this rest, the numericals part will go bad. So that's how you derive it. Let's go through that once again. We know that average velocity is v plus u by 2, and distance is average velocity into time. We need to know that. Now if we take distance is equal to average velocity into time, and that is basically distance is equal to u plus v by 2 into t. Now we also know from this equation here, v is equal to u plus at. So we can fill in the value u plus at by 2 into t. So that will equate to 2u, because u plus u is 2u, simple addition, plus at by 2 into t. Now if we solve this, we multiply this by, because this is a bracket, that's why I said brackets are important, they are not to be left out. We can put it in this way, we can write S is equal to ut plus half at square. It's that simple, and it's very easy to derive. Now let's go ahead with the third equation, which is also pretty simple to derive, but we need to use both the equations in this one. So let's go ahead. I'll be putting this here because we'll be needing it. Let's just turn this around, sorry for that. And the third law of motion, third equation of motion, is v square is equal to u square plus 2as. Very easy. Now how to solve this? We know S is equal to ut plus half at square. We know that from this, what we derived here, S is equal to ut plus half at square, and we also know v is equal to u plus half at square. Now let's get right into it. So S, now if we solve this further, S is equal to u v minus u by 2 plus half. We are filling in the values right now, because we also know v is equal to u plus at. So we fill in the values equal to half a v minus u by a whole square. So we have substituted the value for t. Now you must be wondering, what did we substitute it for? So if we take at is equal to v minus u, we know that. So t is equal to v minus u by a. It's that simple. It's we substituted v minus u by a is for t. We put that there. The value fills in. So the next step is solving this. Solving it is very easy. uv minus u square by a plus a. We solve this half here right now. Plus a v square plus u square plus 2 uv. Now you must be wondering, how did we get three polynomials here? So to explain that, I'll explain it in a minute. 2a square. Here we know that a plus b whole square is equal to a square plus b square plus 2ab. It's that easy. So we know that we expanded this. Basically we use up identities. So physics uses identities, maths plus concepts from there also. Now we'll go ahead and solve this even further. Now which will imply that 2uv minus 2u square plus v square plus u square minus 2uv. We solve this all. We don't need to show it on camera. You can practice and find that out. Is 2a, because a and a get cut here, a square, and then a is here, so we can get that cut. So now let's just get solving more. Now if we can, you see we can cut this both also here, but I'm not going to go ahead and simplify this even further because it'll just take up time unnecessarily, and I'm sure most of you know how to simplify it. So in the end, v square minus u square by 2a will be the thing. Now if we imply it even further, it's 2a s, because s was here ultimately. Now we are putting this here is equal to v square minus u square. If you're wondering how we did this, let's just go here. We brought this, we transposed 2a to here, which is, it multiplies with s because it was division here. So 2a into s, so it's 2as is equal to v square. What's left out here is 2v square minus u square. Now if we do that, it's equal to v square is equal to u square plus 2as. Now this all the three equations of motion are derived, and you know how to find out from one equation you can find out two new actually we need the second equation for finding the third one, but ultimately this is the root. The first one is is the main cause of finding this. Now that you know how to do this, you can solve physics numericals easily. I'll be putting another video out there for solving physics numericals. It will be equally it'll be the same thing, so watch out for that. If this video helped you, please leave a like and subscribe, and if you have any problems, feel free to contact me on my website, or you can even put it in the comment section. Now I gotta go, and I'll see you later. Bye bye.